This is Ashley Owens in the Year 4 Derivative Podcast 2 assignment for calculus. So first I will be explaining trig functions and lines of tangent. So here are all the derivatives of trigonomic functions. And I will be using example 7 from the book, which is sine of x times tan of x. So here we can see that we are applying the product rule, which is first times the derivative of the second plus the second function times the derivative of the first function. So here we have sine of x times the derivative of tangent of x plus tangent of x times the derivative of sine of x. And once we get all of our derivatives down, we will get sine of x times secant squared of x plus tan of x times cosine of x.
Okay, the next rule is the line of tangent rule. Basically what you're going to do is solve for y to find the slope, and then you're going to find the derivative of y, and after that you will find the values and solve for the equation from the y equation and the slope. After that, you're going to incorporate points into the y equation. Okay, now let's get started. Question number 43 from section 3.5 of the Thomas Calculus book. Find all points on the curve y equals tan of x. Pi over 2 is less than x less than pi over 2, where the tangent line is parallel to the line y equals 2x. First, you're going to find the slope. Y is equal to 2x, so the slope is 2 because when you use the formula of y equals mxb, m equals the slope. Next, you're going to find the derivative of the y function, which is y equals tan times pi over 2 plus x plus pi over 2. So you prime your function first, which is y prime. Then you find the derivative of tan of x, which is secant squared of x. And you find the derivative of pi over 2, which is 0 because pi is a number, and when you find the derivative of a number, it becomes 0. Plus x becomes 1, and pi over 2 becomes 0 again. So you rewrite your equation, and your answer is now y prime equals secant squared x times 1, or secant to the second power x. Then what you're going to do, after you have figured out your derivative, you're going to plug in your slope value for x, which will equal y. So it'll be y prime equals 2 times secant squared.
Now I'll be doing example 8, which is g of x equals cosine of x divided by sine squared of x. So in order to find the derivative, I have to do g prime of x, which is sine squared of x times the derivative of cosine of x minus cosine of x times the derivative of sine squared of x all over sine squared of x. Here I am applying the quotient rule. Therefore, sine squared of x times negative sine of x, which I got from the derivative of cosine, minus cosine of x times sine of x times cosine of x all over sine of x squared. Here I broke it down on how to find the derivative of sine squared of x, since there's two variables being multiplied together. Therefore, the answer would be negative sine squared of x times sine of x minus cosine squared of x times sine of x. Now I will be doing example 25, which is r equals secant theta times cosecant of theta. So r prime would be secant of theta times the derivative of cosecant of theta plus cosecant of theta times the derivative of secant of theta. And here again, I'm going to be using the product rule. I applied the product rule, which equals secant of theta times cosecant of theta times cotangent of theta plus cosecant of theta times secant of theta tan of theta. Now, I'm taking this subtraction sign and moving it to the front, and it would be negative secant theta times cosecant of theta, cotangent of theta, plus cosecant of theta times secant of theta tan theta.
Okay, next we're going to do the chain rule. You use the chain rule when the function is more than just x. So you see here, f of g of x equals f prime times g of x times the derivative of g of x. So basically what you're going to do is you're going to keep the outside function, keep the inside function, and find the derivative of the inside function. So number 13 of chapter 3.6 is y equals x squared over 8 plus x minus 1 over x to the 4th power. First, you're going to prime your function, which is y prime equals x squared over 8 plus x minus 1 over x to the 4th power. So now you're going to cover up your inside function, and you're going to bring the exponent, multiply the exponent to the front, so you can subtract 1 from the exponent. So it becomes 4 times x squared over 8 plus x minus 1 over x to the 3rd power times the derivative of the same inside function, which is x squared over 8 plus x minus 1 over x. Then what you're going to do is you're going to bring down the inside function that you did not solve times the derivative of x squared over 8, which is 2x over 8, plus the derivative of x, which is 1, and the negative 1 over x becomes 0 because 1 is a number, and when it's a number it becomes 0. And I'm going to reduce the problem again. So it's going to be, I'm going to reduce the derivative actually from 2x over 8 to x to the 4th power because it can be canceled out. And your final answer would be y prime equals x plus 1 times x squared over 8 plus x minus 1 over x to the 3rd power. And that is your chain rule. Number 25 is s equals 4 over 3 pi times sine 3t plus 4 over 5 pi times cosine 5t. So you're going to prime your function. It's going to be s prime equals 4 over 3 pi times cosine times 3t. And you're going to find the derivative of 3t because cosine is not by itself. Anytime you have a function that's not just by itself, you find the derivative of that inside function. So the derivative of 3t plus 4 over 5 pi times sine times 5t, and then you find the derivative of 5t because cosine is not by itself either. So now what you're going to do is you're going to bring down 4 over 3 pi times cosine 3t, and you find the derivative of the 3t, which is 3, plus 4 over 5 pi times sine over 5t times the derivative of 5t, which is 5. And then after you do that, your answer is now s prime equals 4 over pi cosine times 3t plus 4 pi over sine times 5t. The next equation, the next problem is number 43. F of theta equals sine theta divided by 1 over cosine theta. This rule of this part of the chain rule, you're going to be using the quotient rule. When you're using the quotient rule, you always think about the formula bottom times top minus top times bottom all over bottom squared. So basically, when you find the derivative, you're going to prime your function. It's going to be f prime theta plus 1 plus cosine theta times the derivative of sine theta, which is your top function, minus your top function sine theta, times the derivative of your bottom function, which is 1 plus cosine theta, all over 1 plus cosine theta squared. Okay, so once you've written that, you bring down your 1 plus cosine theta and you find the derivative of sine, which is cosine theta, minus sine, and you find the derivative of 1 plus cosine theta, which is negative sine. Because 1 becomes 0, because a number always, when using derivatives, becomes 0. Okay, now I'm going to multiply the same trigonometry function. So it'll be f prime of theta equals 1 plus cosine theta times cosine squared theta plus sine squared theta all over 1 plus cosine theta squared. Now, when you have your trigonometry function squared, you have to reduce them. I reduce them over here to the side. Cosine squared x equals cosine times cosine, which equals cosine times the derivative of the second cosine function, and that is now cosine x times negative sine x. And I did sine right here too. Sine squared theta equals sine x times sine x, and it now becomes sine times the derivative of sine, and the answer is sine x times cosine x, all over 1 plus cosine theta squared. Now we're going to work on inverse and log functions. This comes from chapter 3.8, number 15. Y equals the log of 3 over x. Basically, when you use log functions, when the function carries a log. And what we're going to do with this problem is you're going to find the derivative of the log and incorporate the appropriate rule to solve for the equation. You can either use the product rule, the power rule, or the quotient rule. The product rule is when you're multiplying a number, a variable, to a power. Yeah, and then the product rule is when it's just only x, when it's more than just x. And the quotient rule is when you're multiplying the bottom function times the top function minus the top function minus times the bottom function all over the bottom function squared. Okay, so back to the problem. Y equals log times 3x, which is, you're going to find the y prime, which is 1 over x times 3 over x. Then what you're going to do is you're going to find the derivative of the inside function. Your inside function is what's in parentheses. So it's going to be y prime equals 1 over x times 3x times the derivative of 3 of x. Then you're going to bring down your first function and your inside function, and you're going to solve for the derivative of this function. So this, you can multiply these two together. This now becomes 3x times the derivative of 3 over x, which is 3x to the negative 1 power.
Now I'll be explaining number 17, which is y equals the natural log of theta plus 1. Therefore, y prime equals 1 over theta plus 1, because wherever you see x, you'll be applying what's in parentheses. Then you will find the derivative of theta plus 1. So the answer would be 1 divided by theta plus 1 times 1. And if you were to narrow that down, 1 times 1 equals 1. And you would just keep the denominator the same. So the answer would be 1 divided by theta plus 1. Next, I'm going to do number 13, which is y equals the natural log of t squared. So y prime equals 1 over t squared times the derivative of t squared, which equals 1 over t squared, and the derivative of t squared is 2t. So now, if you multiply your two functions together, you would have 2t over t squared. And here I noted that since multiplication it goes with division, you can cancel out your t's, which gives you 2 divided by t. So that concludes our podcast assignment. Thanks for watching.
Bye-bye.
Bye.